Okay, here is our last problem, the problem of death. It is the one that I skipped. I'm just going to go ahead and start on a fresh sheet of paper because I do not think that one little smidgen of room is going to be enough. Okay, so to start with, it's going to be just a basic trig substitution. If you look at your choices, okay, and again, you have to pick this out on your own to start with. Which one of these does it look the most like? Okay, so it looks like square root of a squared minus x squared, which is x equals a sine theta. So I'm just going to write that down. Square root of a squared minus x squared, they tell us that would be x equals a sine theta. So again, on your homework, you do have to determine this yourself. Okay. All right. So now, what would our substitution be? You think a by parts is easier? That's what they learn next. All right, so two things we need to do. We need to find dx, and we need to draw a triangle. Okay, so thoughts on dx? Okay, and then the other thing we need to do is draw a triangle. Wait. The derivative of theta is d theta. Okay, so it's like, okay, and then sine theta would be equal to what over what? X over 2. So we're going to draw a triangle that represents that angle. Sine is a ratio of which two sides? Okay. So this will be opposite, this will be hypotenuse, and I need to solve for this missing side. So I'm going to call that b. So I would have x squared plus b squared equals 2 squared. So b squared would be 4 minus x squared. So b is the square root, sorry, that was off the page, of 4 minus x squared. What's that? Yes. Yes, and that's why you choose it that way, so that it will be helpful to you in the problem. Okay. All right, so now we'll go and we'll make our substitutions. So this is x squared. Our x is 2 sine theta. So if we square that, it would be 4 sine squared theta. And then we'd have the square root of 4 minus, and again, it's x squared. So 4 sine squared theta. And then dx is 2 cosine theta d theta. Very common on this is that this is going to turn into one of your Pythagorean trig identities to substitute. So this is 4 sine squared theta. If you factor out a 4, you get 1 minus sine squared theta. That is cosine squared theta, yes. And you're getting that from sine squared plus cosine squared equals 1. So I'll just write that to the side. You don't have to unless it's helpful to you. Okay, so if you rearrange, just subtract sine squared from both sides, you get 1 minus sine squared theta. Okay, so that's what I'm going to substitute in now. So this would be 4 cosine squared theta times 2 cosine theta d theta. Sure. Okay, so you mean, and we can take out this too. Okay, so this would be 2 cosine theta. And we still have this 2 cosine theta. Okay, so what I'm going to do now is I'm going to take out all my constants, so the 4 and the 2 and the 2. Oh, what did I say? Yeah, so 16. And then we have sine squared theta cosine squared theta d theta. Now, this is where your trig identities are going to come in handy. Lots of different things you could do, but there is, on your formula sheet, a nice little thing when you have sine theta and cosine theta. And it's right here. Sine 2 theta is 2 sine theta cosine theta. So I'm going to write that to the side. It's under the trig identities, topic 3. Yeah, I'm just going to have like 2 of them. So I'm just going to write that down. Sine 2 theta is 2 sine theta cosine theta. So what I'd like to do is say that I have 2 of those, because you have sine theta cosine theta, but you kind of need the 2 as well. So I'm going to move 2 of the 2's back in. Okay, so I'm going to have this like 4, and then 2 sine theta cosine theta, and another 2 sine theta cosine theta, d theta. Okay, so I'm just separating sine squared, cosine squared into sine times cosine times cosine, and then just putting sine theta cosine theta and sine theta cosine theta together. Does that make sense? And I really wanted the 2's, so I just took them out of the 16. This is, that's fine. Yes. So this I'm going to replace with sine 2 theta. And this is also sine 2 theta. And sine 2 theta times sine 2 theta is sine 2 theta squared. Do you want to write it as the squared here? It's either way. I'm just going to do. Well, what did we learn yesterday? We had to do anytime we had a sine squared or a cosine squared. We had to go to what kind of formula? Yes, very good. Okay, so we had to go to double angle, and we're using the double angle that has the sine squared in it. Okay, so you're using cosine 2 theta equals, so I'll just write that to the side. Cosine 2 theta is 1 minus 2 sine squared theta. And I need to make sure that looks like cosine 2 theta and not a squared. Okay, so you wanted to take that and you want to solve it for sine squared. So you are, I don't know, I kind of want to make it positive. So I'm going to move the 2 sine squared over here. So add that over and then subtract the cosine. And then you would be dividing by 2. But I don't want sine squared theta. I want sine squared 2 theta. You could, but if you did, you would have sine squared u, and you can't use power rule on it because you don't have the cosine. It would be like, then you'd need a z substitution. Okay, then what would du be? Cosine 2 theta times 2, yeah, and I don't have a cosine. That's the problem. Yes. Okay, so that is correct. Okay, because basically this just has to be twice whatever this is, because it's a double angle formula. So let's see what we've got here. 4 integral of a half 1 minus cosine 4 theta d theta. Okay. And let's go ahead and do it as the integral of 1 d theta minus the integral of cosine 4 theta d theta. And actually, the integration now is not hard at all. We've taken care of that. It's just all the trig substitutions we're going to need to get back to x's that's going to kill us. Okay, it's not really the integration that's going to be terrible, because on this one, what's u going to be? And what's du? And do you have it? Oh, we can fix it. Oh, got me. No, I got it. My d theta's there. Oh, I got you. Okay, so we have 2, and I'm thinking of going ahead and distributing the 2, if y'all are all right with that. So this would be 2 theta, because if you integrate 1, you just get theta. And then the 2 times a fourth, so that'd just be a half. And this is the integral of cosine u du, so what's the integral of cosine? So it would just be sine u. Okay, so you have finished integrating at this point. So you're already patting yourself on the back. You're like, I am the bomb. Okay, but unfortunately it's in thetas, and it's going to take me a few minutes to get this back to all x's, and the real reason it's going to take me so long is that sine 4 theta. Okay, that's going to be the trick. Okay, so this first part is going to be easy, because instead of theta, you can go back up to your problem. If sine theta is x over 2, if you solve that for theta, what is theta? Good. So you can write arc sine or you can write inverse sine, whichever makes you happy. Okay. So I'll just do a mixture just to be crazy. Okay. Now when you get to here, you don't know what the sine of an angle 4 times as big as that is. You only know what the sine of that angle is. So you're going to have to use a double angle formula. Yeah, I told you it was rough. I don't lie about these things. It's not 4 times as big. Yes. What would sine 4 theta be? Okay, because that's it with double angle formulas. This is just half of whatever that was. Okay, so I've got that. So I've got 2 sine 2 theta cosine 2 theta plus c. So I think we might as well just cancel that part, right? So all I need to do is figure out sine 2 theta and cosine 2 theta, and you can use any formula on your formula sheet that you want, because we're going to know everything. Sine 2 theta is on here, 2 sine theta cosine theta, and we know the sine, we know the cosine. Cosine 2 theta, you could use this one, or this one, or this one, because you know all of those things. Okay, so right now instead of sine 2 theta, I don't have a choice on that. That's 2 sine theta cosine theta. Cosine 2 theta, you literally can pick any one of these 3 that you want. And I'm going to pick cosine squared theta minus sine squared theta. And it's going to be tight. As soon as you plug in all of those values, you have this solved. I think I'm going to stop it and render it because I don't think, well, I'm going to stop it. Okay, so I think that you guys were right about here. And so all we're doing from here on is substituting in the trig values. So instead of sine theta, I actually put in the sine of the angle, which was x over 2. So I'm going to put that in everywhere I see a sine, so here and here. And then for cosine, it's adjacent over hypotenuse, so I'm going to put that in.